Jai Jagannath. So, welcome to more physics, and today we will start chapter 21, that is capacitance and dielectrics. So, this is lecture 1. So, what is a capacitor? So, capacitor, from the name it indicates, it is the it is some arrangement where charge and hence electrical energy is stored. So, capacitor is an arrangement. It is an electrical device in which we can store the charge as well as electrical potential energy. And what is the use of these capacitors? So capacitors are used in various fields. So in your mobile there is a camera. So in that camera there is a flash unit. So in that electronic flash unit we can use the capacitor. And in the radio and television receiver also we are using capacitor. And in your house, in the fan, so there is a capacitor. So capacitor gives the instantaneous charge at the time of starting. Okay. So now, in electrical transmission system, we use the capacitance. Now, what is capacitance? The symbol of capacitance is C. So you see, capacitance is defined as it is the ability or it is the capacity of a conductor to store charge. So we cannot give more charge beyond its capacity to a conductor. Okay. So just like you see, suppose you take a glass. So this is a glass. So this glass capacity is 100 ml. Okay. So if you see, so there is certain water. Now if you will add some water to the glass, its level will increase. So after fulfilling the 100 ml of water, if you will add extra water, what will happen? The water will leak from the glass. So that means this glass has capacity to store 100 ml of water. So if you give more water, it will leak. Similarly, for a conductor also, suppose I will take a conductor. Let us say this is a conductor, spherical conductor, any conductor. So if we will add some charge on the conductor, we know all the charges are distributed on the surface of the conductor. Okay. So suppose this charge, now you are giving 10 coulomb charge. Okay. So it can store. Now you give 20 coulomb charge, it will also store. But if you will give 20.1 coulomb charge, we will see it will never store 20.1 coulomb charge. Its maximum capacity is 20 coulomb charge for this particular conductor. Let us take an example. So why so? Why so? So just like if you add extra water in the glass, the water will leak out. The maximum capacity of the glass is 100 ml. So similarly here for this conductor, let us say maximum capacity of the charge is 20 coulomb. So if we will add extra charge, what will happen? You see, so this is the conductor, and this conductor is surrounded by what? This conductor is surrounded by a dielectric medium. This conductor is surrounded by dielectric medium. So what is the other name of dielectric? Dielectric is nothing but insulator or dielectric medium or insulating medium. Okay. So let us take an air. So dielectric medium is nothing but the air. So air, the molecule of the air consists of the various small electric dipole. Okay. So now see, if you will increase the charge, if the charge stored in this conductor increases, what will happen? So if charge value increases, then electric field strength also increases surrounding to the conductor. So if electric field intensity increases, what will happen? This electric field intensity will exert a force on this dielectric molecule. So if, and so what is the direction of the electric field here? So since it is a positive charge conductor, the direction of the electric field is away from it. So this is the direction of the electric field. Now, due to this electric field, a force will exert on this dielectric molecule. Okay, so by which the negative charge of this dielectric molecule will come towards this positive charge body, and positive charge of this dielectric molecule will move away from the positive charge body. So now what happens? If we give more charge, then electric field increases. If electric field will increase, then the charge on this dipole of the dielectric medium will experience a force. And since when any charge particle is brought inside an electric field, the charge particle will experience force. And what is the direction of the force? If the charge is positive, that positive charge will move along the direction of electric field, and the negative charge will move opposite to the direction of the electric field. Okay, so now see, if we increase the electric field strength, more force will exert on these molecules, on this charge of the dielectric molecule. So here the negative charge will start moving towards this body, and positive charge will move away from the body. That means initially this medium was behaving as insulator. So now if the electric field intensity is more, then more force will exert on this molecule, so that this negative charge and positive charge will move along the dielectric medium. So that means this insulating medium will now behave as a conducting medium. Okay, so now if we will increase Q further, what will happen? Electric field intensity will also increase. So after some time we will see, after some value of electric field intensity we will see, this negative charge will come to the positively charged body, and positive charge will move away from the body. So that means this dielectric medium will behave as a conducting body. So now suppose initially there was 20 coulomb charge. So now if you will try to increase the charge from 20 coulomb to 20.1 coulomb, what will happen? The electric field intensity will increase, so that this negative charge will come to the surface. Suppose negative charge is coming to be minus 0.1 coulomb. So you had given 20.1 coulomb, and this minus 0.1 coulomb will added here, so that net charge will be 20.1 plus minus 0.1, that is equal to 20 coulomb. So this maximum capacity is 20 coulomb. Okay, so if we will go beyond that value, it will not store the maximum, or it will not store more than 20 coulomb charge due to this phenomena. Okay, so now suppose you will try to give 22 coulomb charge. So if you will give 22 coulomb charge, electric field intensity will further increase, and due to this electric field intensity, the more charge will come towards this positive charge body from the dielectric medium. That means dielectric medium polarizes. So dielectric medium will behave as a conducting body. So now you had given 22 coulomb, but due to high electric field strength developed in the dielectric, so minus 20 coulomb, minus 2 coulomb charge, let us say, added to the surface. So 22 again plus minus 2, that is total 20 charge can store maximum. Okay, so that is why capacitance is the capacity of a conductor to store charge. So it has the capacity to store maximum charge of 20 coulomb. Beyond that, if you will try to add some extra charge, the charge will leak. Okay, so now question comes, what is the minimum value of the electric field strength which will break down this dielectric medium? That is, at a particular minimum value of electric field intensity, this dielectric will break, and that dielectric medium will behave as a conducting body. So that minimum electric field strength is called your breakdown strength. That is called breakdown strength. Okay, so this is called breakdown strength, whose unit is what? This is electric field intensity. So you know electric field intensity is volt per meter. So breakdown strength of a dielectric medium is measured in terms of volt per meter. So this is the definition of breakdown strength. It is a minimum electric field at which the dielectric medium, which is nothing but insulating medium, will start behaving like a conductor. Okay, so that minimum electric field strength is called dielectric strength or breakdown strength, and it is measured in volt per meter. Okay, so we know and that so during that electric field strength, the corresponding potential of the conductor is called breakdown voltage. Now you see, suppose this is the conductor. If you increase the charge, potential will also increase, electric field will also increases. So at a particular minimum electric field strength, the dielectric medium will break and it will behave as a conducting path. And corresponding to the minimum electric field intensity, the voltage is called breakdown voltage. And this breakdown voltage concept we will discuss in the electronics chapter. Okay, so you know, so we know the dielectric strength, that is minimum electric field strength at which the dielectric medium behaves as a conducting medium. So this dielectric strength of air is 30 kV per centimeter. Okay, so this is the design value of air. So air dielectric strength is equal to 30 kV per centimeter. Now question comes, we had taken an example of a metallic spherical conductor where charge is given positive. So what will happen if the negative charge body is taken? Suppose I will take a metallic sphere on which I will give a negative charge of minus q. Okay, so what will happen? If the amount of this negative charge, the magnitude of the negative charge increases, what will happen? So if negative charge magnitude, that is q, increases, again electric field intensity increases. But since it is a negative charge, what is the direction of the electric field? So direction of the electric field is towards it. We know electric field is always towards to a negative charge body. So here this is the direction of the electric field. So if I will take a molecule, dielectric molecule, so here this electric field will experience the force on positive charge along the direction of electric field. That means positive charge will come here and the negative charge will move opposite to the direction of electric field. So now if the electric field strength increases, so what will happen? Force will increase, and due to that force, this positive charge will move towards this negative charge body. And this negative charge body will move towards infinity. So here when positive charge will come to the surface and it will be added with the negative charge, so net charge will decrease. Net charge will decrease. So any conductor has a capacity to store maximum charge, just like a glass. Okay, I had given the example. So now we will compare. The suppose you take a flat spherical conductor. This is a flat spherical conductor. Okay, you take of same shape, same size, but in a different shape. So this is conductor A, this is conductor B. Okay, so here what happens? This is the flat surface. So flat surface means it can store more charge. It can store more charge. That is capacitance here is more. But in this case, what happens? You see, in this point, so there is a sharp shape of the conductor. So here, if you take the radius of this curved surface, so this radius of the curved surface is less. So if the radius of if this radius of this curved surface is less, then area of cross section of this cross section would also less. And what is surface charge density? Surface charge density is nothing but charge per area. Since area decreases, so surface charge density will increase. And what is the formula of electric field intensity for a flat surface like this? So it is directly proportional to sigma. So if sigma increases, that is surface charge density increases, then electric field intensity will also increase. If electric field strength will increase, the molecule, dielectric molecule just near to this will polarize. So if electric field will increase and it will reach to its dielectric strength, what will happen? Suppose this is positive charge, this is positive charge, then negative charge will come towards the surface. So net charge decreases. That means capacity decreases. Okay, so here capacitance or capacity of this metallic spherical conductor is more. This is for flat surface, but for this type of shape of the conductor, the capacity decreases. So what is the conclusion? Conclusion is that capacitance, which is the property of a metallic conductor which will store the charge, so that capacitance depends on size and shape of conductor. You see, for this shape and for this shape, the capacity are different. Okay, so depends upon size and shape of the conductor. Just like you see, you take, this is a glass, and I am taking same dimension, same length glass, but higher length. So here capacity of this glass, let us say this is A, this is B. So capacity of this glass B is more than capacity of A. So capacity of a glass depends upon size of the glass. And if I will take a different shape of the material container, so here, so let us say this is C. So capacitance of C is greater than capacitance of A. Okay, so the capacity of any container depends upon size as well as shape. Similarly, capacitance depends on size and shape of the conductor. Now, second factor is, this is first, it depends on size and shape of the conductor, and capacitance also depends on the nature of medium, nature of dielectric medium. Suppose this is a conductor. This conductor is surrounded by a dielectric medium. Okay. So now see, if I will take a strong dielectric, what will happen? More electric field or more the dielectric strength of the dielectric medium is more. If the dielectric strength of the medium is more, then it can store more charge. Okay, because more force is required or more electric field is required to polarize this dielectric molecule. Okay, so if we'll take a strong dielectric medium, then capacity increases. If we'll take a weak dielectric, whose dielectric constant value is less or relative permittivity value is less, in that case, less amount of electric field can polarize this dielectric medium, can break the dielectric medium. So in that case, the charge capacity of the conductor will decrease. So that means the capacity of a conductor depends upon nature of dielectric medium. Okay, so capacitance depends upon size and shape of the conductor, and it also depends upon the nature of dielectric medium. Now, what is the mathematical formula of capacitance of a conductor? Okay, so you see, I am discussing only one spherical conductor or any type of conductor. Okay, so here let us say the surface, on the surface charge is Q. So due to this charge, potential on the surface is V. So we know if charge increases, potential also increases. That implies we can say potential is directly proportional to Q. Or we can say charge stored by the conductor is directly proportional to potential difference between what? Here always we take potential difference. Here if the potential at the surface is V, then potential on the earth surface is 0. So what is the potential difference between this conductor and earth? It is V minus 0, that is V. So charge amount on the conductor is directly proportional to potential difference, or you can say Q is equal to some constant into V. So that constant is C, which is equal to Q by V. So this C is called capacitance. This C is called capacitance of a conductor. Now how can you define this capacitance? If V is equal to 1, if the potential difference between conductor and earth surface is 1, then C is equal to Q. So that implied we can define capacitance of a capacitor is equal to amount of charge required to raise unit potential difference between conductor and earth. Okay, so I can define definition of capacitance, that is capacitance of a capacitor. Capacitance of a capacitor is amount of charge required to raise unit potential difference between the conductor and earth. Okay, so generally we take potential on the earth surface is equal to 0. So this is the definition of potential difference. Just like you see, suppose this is a glass and I am taking another glass. So here let us say this level is 5 centimeter height of the water is there. Here also there is 5 centimeter height of water is there. Now you pour some water in both container and increase the water level from 5 centimeter to 6 centimeter. Here also add some water so that the water level will increase from 5 centimeter to 6 centimeter. Okay, so here initially there was 5 centimeter level of water, here also 5 centimeter level of water. Now I will add here Q1, suppose I will add some water here, let us say M1 mass of water. Here I am adding M2 mass of water, but we are increasing the water level from 5 centimeter to 6 centimeter in both case. That means we are increasing the water level by what height? 1 centimeter. So to increase the level of water in both container by 1 centimeter height, you definitely say that sir, here more water is required to increase the level from 5 centimeter to 6 centimeter comparing to this. That means capacity of this glass, capacity of the second glass is more than capacity of the first glass. So you can define what is the capacity of a glass. Capacity of a glass is amount of water required to raise unit level of the glass. Similarly, so this is the definition of potential capacitance of a conductor. Okay. Now see, suppose there are two conductors. So here the charge is 10 microcoulomb, where potential is 20 volt. Here for same potential difference 20 volt, here it can store 15 microcoulomb charge. So we can say C2 is greater than C1. For same potential difference between conductor and earth, that is 20 volt and 20 volt, it possesses or it can store more charge comparing to this. So capacitance of this spherical conductor is more than capacitance of this. Okay. Then a question comes, what is the unit of capacitance? Unit of capacitance. So you know C is equal to Q by V. So in SI system, the unit of charge is coulomb, unit of potential is volt, and coulomb per volt is called farad. And what is the symbol of farad? That is equal to F. So now generally the farad is very bigger unit of capacitance. So we can take, so capacitance unit is microfarad, millifarad, nanofarad. Micro means 10 to the power minus 6, milli 10 to the power minus 3, nano 10 to the power minus 9 farad. Okay. So next is your dimension. So you can say, question may comes, define 1 farad. Define 1 farad. So 1 farad is nothing but 1 coulomb by 1 volt. Now we can define 1 farad capacitance is equal to, if 1 coulomb charge is required to raise 1 volt potential difference of a conductor, then the capacitance of that conductor is called 1 farad. Then what is the dimensional formula of capacitance? Now C is equal to what? Q by V. That is Q by V. What is V? Potential difference. We have already discussed in the potential chapter. It is the amount of work done by bringing a unit charge from infinity to that point. So Q by V is W by Q. That is equal to Q square by W. What is Q? Q is equal to current into time. That is ampere into time is equal to charge. So Q square is equal to AT whole square divided by work done. What is work done? ml square t minus 2. So that is equal to m minus 1, l minus 2, t minus here t square, here t fourth, and a square. So this is the dimensional formula of the capacitance. And capacitance is which quantity? Definitely it is scalar quantity. Capacitance is scalar quantity. And it is always positive value. Capacitance is always positive value. Why? You know C is equal to Q by V. So if Q is positive, then potential is also positive. So C is equal to positive. If Q is negative, if charge given is negative, potential is also negative, then capacitance is again positive. So capacitance is a positive. Now see, suppose there are two conductors. Here charge stored is 4 millicoulomb, voltage is 0.2 volt. What is the capacitance? Capacitance is equal to Q by V. So here that is 20 millifarad. So here the charge stored in the capacitor is 20 millicoulomb. Voltage is 40 volt. What is the capacitance? 10 millicoulomb by 40 volt, that is 0.25 millifarad. Okay. Now one interesting point is that you see, suppose this is a glass. Okay. So here this glass contains let us say 10 milligram of water. Now I am taking another glass. So which is full of water. Let us say it is 20 milligram. Now if question comes, which glass has more capacity? So don't tell, so let us say this is A, this is B. Don't tell capacity of B is greater than capacitance of A. So you don't tell like this, because in this B, so full water is given 20 milligram. But here I have given 10 milligram water, but its capacity is more, to store more water. So that means capacity of glass does not depend on water. It does not depend upon water. So here 10 milligram water is there. That does not mean its capacity is less compared to this. Here more 20 milligram of water is there. So we cannot say capacity of this glass is less than the capacity of this. Suppose, for example, this is a very fat man. So this man can take 2 rotis in the dinner. And this is a very thin man, but this man is taking 4 rotis. That does not mean that capacity of this man is less than this, because since he is fat, so according to the advice of the doctor, he is taking 2 rotis, but his capacity can take 8 rotis or 10 rotis. Okay, so what is my point of discussion here? You see, we know capacitance is equal to Q by V. So if Q increases, V also increases, so that the ratio between Q and V will remain constant. And if Q decreases, V also decreases, so that capacitance remains constant. So that means capacity does not, or capacitance of a conductor does not depend upon the change in charge and change in potential. So I am writing, this is very important. So does not capacitance does not change with change in charge and or voltage. So capacity does not depend upon the charge, change in charge or change in voltage. It depends upon what? Capacitance depends upon, I have already told, shape and size of the conductor and the nature of dielectric medium. Just you take the example here. You take the example. What is the resistance of a conductor? It is potential difference by current. Okay. So resistance is equal to V by I. So if V increases, current also proportionality increase, so that resistance remains constant. Of course, there is a limitation at what temperature? Constant temperature. So at constant temperature, resistance is constant. It does not depend upon voltage and current. If voltage increases, current also proportionally increase. But we know resistance is equal to rho L by A. So resistance depends upon length of the conductor, area cross section of the conductor. So resistance depends upon the dimension of the conductor. We can say shape or size of the conductor, or resistance depends upon dimension of a conductor or geometry of the conductor. And also resistance depends upon what? Rho. Rho is called specific resistance. It depends upon nature of material. So similarly, C is equal to Q by V. It does not depend upon charge as well as V. Okay. So now we will discuss the capacitance of metallic spherical conductor. Capacitance of metallic spherical conductor. Suppose this is a spherical conductor. The radius of the spherical conductor is R, and we are giving the charge to this spherical conductor. And in any case, since it is a conductor, all charge will reside on the surface according to the Gauss law we have already proved. So now you see, let us say the capacitance of this capacitor is C. Okay, so now the electric field will start from positive and end on infinity. So here C is equal to Q by V. And we have already derived the formula of potential due to a spherical conductor is equal to what? K Q by R. That is equal to Q cancel, that is R by K. But what is K? K is equal to 1 by 4 pi epsilon naught. So K is equal to 1 by 4 pi epsilon naught. So that means 4 pi epsilon naught into R. So this is the capacitance if the medium is air. So you can write this is the air capacitance of a spherical conductor whose formula is equal to 4 pi epsilon naught R. Remember, 4 pi epsilon naught is here 1 by 9 into 10 to the power 9. But if the medium is other than air, then what is the formula? So capacitance in case of any other medium is equal to R by K, but here K is equal to 1 by 4 pi epsilon naught epsilon R. That is equal to 4 pi epsilon naught epsilon R into R is the capacitance of a spherical conductor other than air medium. So now we can find if the capacitance of a medium is given 10 microfarad capacitance of same spherical conductor in air medium is given 2 microfarad, then what is the dielectric constant or relative permittivity of that medium? So you see, if we will divide capacitance in medium to capacitance in air, so what will happen? So capacitance in medium by capacitance in air, just divide this to this, you will get epsilon r. So here epsilon r is equal to 10 by 2, that is 5. And relative permittivity has no unit. So that means you see from this formula, capacitance depends upon R. R means geometry of the conductor. Epsilon R, nature of the dielectric medium. So we have already discussed the capacitance depends upon two factors. Now see, so what is the capacitance of earth? So you know, earth will behave as like a conductor, and earth is spherical in nature. And what is the radius of earth? We know radius of earth is equal to 6400 kilometer. In terms of meter, it is 6.4 10 to the power 6 meter. Then what is the capacity of earth? Capacity of earth or capacitance of earth? It is equal to, 4 pi epsilon naught into r. That is equal to, r is equal to 6.4 10 to the power 6 divided by 4 pi epsilon naught is nothing but 1 by 9 into 10 to the power 9. So if you will calculate, you will get 711 microfarad. Now see, generally the earth radius is very large. So with that very large radius, we are getting 711 microfarad. Okay, but yes, so generally in our environment, we will take a metallic conductor, spherical conductor, whose radius is very less compared to earth. So since capacitance is directly proportional to R, if R decreases, capacitance of the metallic spherical conductor also decreases. So maximum capacitance of Earth's surface we are getting 711 microfarad. Suppose I want to design a capacitor whose value is yours, let us say 900 microfarad. In that case, you imagine the radius of the metallic spherical conductor, we have to take more than 6400 kilometer, which is not possible. Suppose you see, let us take an example. Design a capacitor of capacitance 1 microfarad by using a spherical conductor. So if I will take a spherical conductor and I have to design the capacitance value of 1 microfarad, then what should be the radius of this spherical conductor? So you know what is the formula? C is equal to R by K. That is equal to 4 pi epsilon naught R. So here C is equal to 1 micro. Micro means 10 to the power minus 6 farad. 4 pi epsilon naught is nothing but 1 by 9 into 10 to the power 9. So if you will find, then you will get R is equal to 9 into 10 to the power 9 into 10 to the power minus 6. That is 9 into 10 to the power 3 meter. So 9 into 10 to the power 3 meter means 9 kilometer. You imagine, in your radio, we are using 1 microfarad capacitor. But to design 1 microfarad capacitor, if I will take a single spherical conductor, its radius is 9 kilometer. Imagine 9 kilometer is the distance of from one city to another city, or from one town to another town, 9 kilometer. So it is not possible. So definitely there must be some arrangement where we can get more capacitance in less space. So definitely we will do some arrangement where we will get more capacitance but in less space. So that is original capacitor. Original capacitor means we have to arrange in such a way that in the less space we will get more capacitance. For that we have to use two parallel plates. We have to use two parallel plates. Okay, so now what is the actually disadvantage? So I have already told what is the disadvantage of spherical conductor, or simply one spherical conductor. Disadvantage of one spherical conductor or capacitor we have already discussed. For 1 microfarad capacitance we require 9 kilometer radius spherical conductor. So large radius of conductor is required for low capacitance value. So in this case, space requirement will be more. So, and second disadvantage is that energy is not bounded. It is distributed to infinity. You see, if I'll take a single conductor, then this is your supposed charge. So here, this is the direction of the electric field. Electric field extends up to infinity. So the total energy stored will be within this surface to the infinite value. That means energy is not bounded by a certain area. Okay, that is the disadvantage. So to overcome these disadvantages, we have to take special arrangement. That special arrangement is called capacitor, which is also called condenser. In this condenser or capacitor, instead of one conductor, we will take two conducting surface separated by a thin layer of dielectric medium which stores charge and electric energy by the electrostatic stress in the dielectric. Suppose I will take this is a plate, this is another plate. We have to maintain the distance of separation between these two plates is very small, and inside this two plate, so there is a dielectric medium, and if it is a positive plate, if it is a negative plate, there will be an electric field developed in between positive to negative, and so that means this dielectric will be stressed. On this dielectric medium there will be a force. That force is nothing but force due to electric field, and due to that electric field some energy will be stored within this area, within this boundary. The total energy will be stored. So that arrangement is called condenser or called capacitor. In the next class we will discuss the principle of this capacitor. So till that, take care. Okay, bye.